Good morning students, 12th standard physics, so lesson 3 magnetism. So in this class we are going to discuss about classification of magnetic materials. So the magnetic materials, how it behaves in the presence of magnetic field. So that magnetic materials are classified into three types: diamagnetic, paramagnetic and ferromagnetic. So in this class specifically we are going to discuss about diamagnetic materials. So already we know the orbital motion of electron around the nucleus produces a magnetic field. So that magnetic field is perpendicular to the plane of the orbit. So consider, so the electron revolving around the nucleus. So that due to the orbital motion of electron revolve around the nucleus produces a magnetic field perpendicular to the plane. So just see, it's a horizontal direction, electron moves, but magnetic field is perpendicular. So see the angle between the direction of electron and direction of magnetic field. So do electron revolve around the nucleus, due to the orbital motion of electron produces a magnetic field. That magnetic field is perpendicular to the plane of the orbit. So this is the plane of the orbit, that is horizontal line, that is perpendicular line is, that is vertical line. This is the direction of magnetic field. So due to the orbital motion of electrons, there is a orbital moment produces, that is magnetic moment Pm. So its magnetic moment is oriented in random manner. So previous class we had discussed, so the direction of magnetic moment in random manner. So the resultant magnetic field, that is vector sum of the magnetic field, is 0. Then so due to that no resultant magnetic field, that is there is no magnetic moment for each atom. So each atom have so many electrons, due to the so many electrons revolve on the nucleus, you will get a magnetic field. Then the magnetic materials, so inside the magnetic material we are discussing that magnetic materials, if you place in a uniform magnetic field. So if a magnetic materials are placed in the uniform magnetic field, the electrons present in the atom, it's speeded up due to the presence of external magnetic field. So that magnetic field produces induced magnetic moment in the direction opposite to the field. So for example, the electrons are speeded up in this direction, the external magnetic field in opposite direction. So this is according to Lenz's law. So we will study in the lesson 4. So the induced magnetic moment is produced in the direction opposite to the field. But if you remove the external magnetic field, the induced magnetic moment disappears. So this is a disadvantage for diamagnetic materials. So we can't use as a magnetizing material. So next, if you place the diamagnetic materials are placed in a non-uniform magnetic field. So what is the difference between uniform and non-uniform magnetic field? Uniform means same direction, constant magnitude. Here this is non-uniform magnetic field. So see the direction of the magnetic field lines somewhat differ than magnitude here. What is the magnitude here? What is the magnitude here? So somewhat high and low. See here, what is the magnitude? Same, it's uniform. So if you place a material in non-uniform magnetic field, so see, so this is a diamagnetic materials, if it is placed in a non-uniform magnetic field. So already we know, if a diamagnetic material is placed in a magnetic field, induced magnetic moment produces, as well as, so due to the induced magnetic moment, there is an interaction between the external field, that is external field and induced magnetic moment. So it creates a force. So that force moves the material from stronger part to weaker part. See, in the uniform magnetic field, this is a stronger part, more magnetic field lines flows. Here less magnetic lines fields. So the material is moved from stronger part to weaker part. So if you place in uniform magnetic field, what will happen? There is a protection of induced magnetic moment. But if we remove the external magnetic field, the induced magnetic moment disappears. But in the case of, if you place the same material in non-uniform magnetic field, there is an interaction between induced magnetic moment produced as well as the external field. It produces a force, it creates a force. That force pushes or moves the material from stronger to weaker part of the external magnetic field. So that part is diamagnetic materials are repelled by the field, that is using the external field. This action is called diamagnetic action. Then what are the examples for diamagnetic materials? Bismuth, copper, water. Then what are the properties of diamagnetic materials? So they may ask in 3 marks. So the magnetic susceptibility is negative. The value of magnetic susceptibility is negative. Then relative permeability is slightly less than 1 for diamagnetic materials. then magnetic field lines are repelled or expelled by the diamagnetic materials when it is placed in the magnetic field. So this is seen now. See, so this is a magnetic material, that is diamagnetic material. So if it is placed in a magnetic field, that magnetic field are excluded out. So if it is a diamagnetic material, so same effect is in the superconductors. For example, mercury at 4.2 Kelvin. So we have studied in lesson 2, that is at transition temperature, that is 4.2 Kelvin is minus 268.8 degrees Celsius. At that temperature, the resistance of the mercury goes to 0. So resistance 0 means the conductor becomes superconductors. So the magnetic field is excluded out. The same effect is sensed by the diamagnetic materials. If it is placed in a uniform magnetic field, the magnetic field lines are, so the magnetic field lines goes into the material. If it is a diamagnetic material, the magnetic field lines are excluded out or repelled. This action is called diamagnetic action. Then final one, that magnetic susceptibility is temperature independent. So if you increase the temperature of the material, there is no change in magnetic susceptibility. So they may ask what are the properties of diamagnetic materials. So what we have seen in this class, so how the magnetic field is produced if orbital motion of electron, the material is placed in uniform magnetic field, induced magnetic moment produces. If it is placed in non-uniform magnetic field, there is a force created due to the interaction between induced dipole moment and external magnetic field. So it creates a force, that force moves a material from stronger part to weaker part of the external magnetic field. Then finally, what are the properties of diamagnetic materials? Okay students.